Have you ever just stopped and wondered how your music app seems to know exactly what you want to hear next? Or how your email inbox just magically filters out all that junk? Well, today we're going to pull back the curtain on that magic. We're going right under the hood to see the engines that power modern AI. Okay, let's get into it.
Right? So it's not actually magic, it's a really fascinating field of science. And the answer to all these questions, from your custom playlist to your phone unlocking with your face, it all starts with one single powerful idea.
And that big idea is machine learning. Seriously, think of it as the core engine driving pretty much every single smart feature you use every day. It's all about teaching computers a brand new and, frankly, incredibly powerful skill, the ability to actually learn for themselves.
So what does that really mean in plain English? Well, instead of a programmer sitting there typing out thousands and thousands of if this, then that rules, they just give the computer a massive amount of data. Then they give it an algorithm that lets it figure out the patterns all on its own. It literally learns from experience, kind of like we do.
And for a long time, that was the main way we built these smart systems. But then, a new approach came along. It was a more complex, way more powerful type of machine learning that took everything to a totally different level.
And that is deep learning. The difference here is absolutely key. See, traditional machine learning often needs a human to kind of nudge it in the right direction, to point out the important features in the data. It's fantastic with organized stuff, like spreadsheets. Deep learning, on the other hand, can find those important features all by itself, which makes it a master of messy, unstructured data. We're talking images, audio, tons of text. The only catch? It can be way harder to understand how it got to its answer. It's more of a black box.
Okay, so if we're teaching these systems, what do the lesson plans actually look like? Well, it turns out there are three main ways, three core strategies for training an AI. First up is what we call supervised learning. And honestly, the flashcard analogy is perfect. You show the machine millions of pictures that are already labeled, like a picture of a cat with the label cat. You do that enough times, and eventually it learns to spot a cat in a brand new picture it's never seen before. This is the workhorse behind stuff like fraud detection and credit scoring. You give it the question and the answer over and over until it learns the pattern. Next, we have unsupervised learning. Now for this one, we don't give the machine any answers. We just hand it a giant messy pile of data and basically say, go figure it out. Find the interesting groups in here. It might discover totally new segments of customers who all buy similar things. Or it might spot a single weird transaction that doesn't fit any normal pattern. It's all about finding those hidden structures all on its own. And finally, there's reinforcement learning. This is exactly like training a pet. The AI tries to do something. If it's a good action that gets it closer to its goal, boom, it gets a reward, a little digital treat. If it messes up, it gets a penalty. Over millions and millions of tries, it figures out the best possible strategy to get the most rewards. This is the brains behind incredible robotics, complex trading systems, and even those recommendation engines. Now, these methods have been around for a while. So what changed? What caused this recent explosion in AI, with all these tools like ChatGPT popping up everywhere? Well, the answer lies in one very specific, very powerful deep learning architecture. It's called the transformer. And I am not exaggerating when I say that this single architecture is pretty much the biggest reason for the massive AI boom we are living through right now. It is, without a doubt, the dominant force in the game today. So what's its secret sauce? Well, first, it understands context like nothing before it. It can see how a word at the start of a long paragraph relates to a word at the very end, which is a game changer for things like translation or summarizing text. Second, it processes all the words in a sentence at the same time, not one by one, which makes it incredibly fast. And third, and this is the big one, it's massively scalable. The more data and the more computing power you throw at it, the smarter it gets. This is the engine that makes large language models possible. But, building these models isn't just about having a clever algorithm. It's a whole engineering process. You can think of it like a factory assembly line that takes raw data and turns it into a real working AI application. The whole thing starts, of course, with gathering a ton of raw data. Then comes what is arguably the most important and difficult part, cleaning and preparing that data. It has to be just right. Only then can you actually train the model. After that, you test it like crazy, and if it passes, you deploy it out into the real world, where you have to constantly monitor it to make sure it's still doing its job correctly. Okay, so we have covered a lot of ground here, from different ways of learning to the whole assembly line. But Why is it so important to actually get a handle on these basic building blocks?
Because here's the absolute truth. Everything, and I really mean everything, in modern AI is built on these core machine learning and deep learning principles. There are no shortcuts. This is the foundation of it all. So here's the real takeaway. When you ask your smart assistant a question, or when you get that perfect movie recommendation, or use an AI tool to help you write an email, you are interacting with a system that is standing on the shoulders of all these foundational ideas we just walked through. It is all built on this bedrock of learning from data.
Understanding this foundation isn't just about knowing how today's tech works. It lets us ask the most important question there is. Now that we have these unbelievably powerful tools, what incredible new things are we going to build next? Thanks for tuning in.